Welcome, ladies and gentlemen, here to the Forum of Hydrogen and Fuel Cells Europe here on Hannover Messe 2022. We are live here, we are back again, and we have a panel discussion right now with a clean energy partnership. It is about future truck mobility, discussing heavy-duty refueling path, and I would like to talk a little bit about the clean energy partnership. It's an industry partnership to establish green mobility with hydrogen and fuel cells. It unites technology, petroleum and energy companies, gas producers, car manufacturers, and suppliers to work together. 4 of them we have here with me. I would like to welcome right next to me Tom George. He is Chief Operating Officer of Clean Logistics. Welcome to you. Next to him sits Nicolas Iwan, is CEO of H2 Mobility Deutschland. Welcome, Mr. Iwan. Dr. Thomas Acher, I would like to welcome. He's Head of Process Design and Development of Linde Hydrogen Fuel Tech. Welcome to you as well. And Dr. Nicolas Dohn, opposite of me, Business Manager Wasserstoff Westfalen AG. Welcome also to you. And you can participate in discussion, of course. Whenever you have a question, just raise your hand. I'll be with the microphone directly with you, and you can ask your question directly. Mr. George, our topic is future truck mobility. And in Germany, we are committed to reduce CO2 by 55% in 2030. How will we get there? What is your idea?
So my idea is definitely that trucks and buses, so especially heavy-duty trucks, are a major portion of this CO2 reduction, and that's why we have the vision to produce zero-emission trucks in large scale using hydrogen as the main energy carrier. So in the end, trucks are not the only thing we have to do, but they are an essential part to reduce CO2.
To go that path, indeed. Mr. Iwan, H2 Mobility were involved in the installation of more than 150 hydrogen refueling stations in Europe, most of them in Germany, we have to say. Before we focus on truck mobility, just the first question, what do you think about passenger cars with fuel cells?
Well, you may be aware that we have just managed to attract a new investor. When I spoke to him and to the others we had in the panel, then they asked us as well the question, what about the different segments? And my answer was the business case now and in the next 5 years with hydrogen is in the regional haul segment. So what you just mentioned, the trucks for the medium distance and the buses. The business case tomorrow, so in the next 3 to 5 years starting, will be heavy duty, and the business case thereafter will also be in the light segment. I believe that there will be a ramp up, and I think that the likelihood is high that hydrogen will also have a significant market share there. But the uncertainties today in Germany are probably highest when we speak about those different segments for hydrogen.
So you do believe if there's a ramp up in the passenger car area, we will all buy Toyota and Hyundai then, or even German or European car makers will go that path?
Well, I'm an optimist, sometimes an over-optimist. Therefore, don't take me too seriously, maybe. But I still believe that the German OEMs will also find that hydrogen may be a good solution. Maybe first Japanese and Korean cars, maybe second Chinese cars, and then hopefully third as well cars from a German producer.
Hope you're right, indeed. Dr. Acher, you're from Linde. How many of these hydrogen refueling stations we were talking about have you built? How many of them?
Yeah, we take pride in having constructed more than 200 hydrogen refueling stations worldwide, and also ranging from a wide spectrum of applications. So we talked about passenger cars, but we also have solutions for buses, trucks, as well as trains. So we have quite an extensive expertise for various applications in hydrogen mobility.
And you provide these refueling stations with hydrogen, but this is usually hydrogen made by steam reforming, right?
Yeah, well, this is the current problem we have at the moment, that a lot of the hydrogen that is on the market is still conventionally produced. But as you can see when you look around this hall, there's a lot of ideas how we can make this greener. And for us, it is also the intention of having the right equipment, the right technology that best suits the transition from gray over blue to green hydrogen.
And together with your partner ITM, you also produce electrolyzers for green hydrogen. What is the percentage at the moment of green hydrogen that Linde produces of all hydrogen? Could you tell me? Is it 1 or 2%?
This is difficult for me to answer since, well, I'm specialized when it comes to the technology we have in hydrogen refueling stations. But I know that also in the company there's a large intention of ramping up the percentage. But it's a long way. I mean, we have expertise, conventional production of hydrogen over 100 years, and now the expectation is to switch in a relatively short period of time to a green production of hydrogen. It will take some time.
Dr. Dohn, building up a hydrogen refueling station is one thing, running it is another one. Your first HRS was built in 2016, and you're still the operator. I think it was not the cash cow so far, was it?
We have our board member sitting here. I should be super careful what I'm saying today, but actually I'm afraid you're right. By the way, it's Linde station. It's running very well. No, I think it's one of the main points you're touching. What we did in the past, what also Westfalen did in the past, is to hope to put a piece of infrastructure and the market will develop around it. I think we have to go for a more holistic approach. Approach where we partner much more than we do today, to have a system in place where we think from various aspects, various perspectives. I think we need to have the station, obviously, but we have to bring it together with the molecules. We need to have the molecules available in the right color. That means the renewable energy directive needs to be, let's say, needs to be covered in order to make it a truly green and acceptable molecule. Then you have to bring the customers, getting the molecules in the end, and you should not forget one point, which is partners in form of OEMs, ideally, that bring the trucks, that bring the heavy-duty vehicles. It doesn't have any value if you bring all the other parts together and you forget the trucks. In our opinion, I think that's one of the crucial points in the next couple of years. The speed that we will see in the market, in the ramping up of hydrogen heavy-duty infrastructure, will be the speed in which the OEMs, the retrofitters, like Clean Logistics, for example, are able to bring those kind of trucks into the markets. I guess we will not see two speeds. We need to have one speed together and to have one holistic approach bring to the customer. And if everyone is happy, if the customer is happy, we can excel in that.
Would you say it was a mistake not to think about trucks at the very beginning of building hydrogen refueling stations? Because a simple passenger car does not take so much hydrogen, it will not count in the end.
Actually, that's what we did. We tried to think two ways. We thought in passenger cars, so we have a 700 bar outlet of our station. And we thought in heavy duty, we have a 350 bar outlet. We are so far one of the 6 stations that are publicly available in Germany where you can get 350 bar heavy duty standard. And actually it was meant to fuel public transportation, to fuel buses. So I hope we have no one of the city of Münster sitting here with us, but there were 4 buses about to come. Actually there was one in 2020. We're still waiting for the 3 other ones. But we see that bit by bit, actually, we get questions from companies, from logistic companies around the city of Münster that are super interested in buying trucks. And I'm very sorry I cannot disclose those names, but there are a couple of big names associated with it. And actually, they ask for subsidies, and as soon as they have that, as soon as they have the trucks, we will see a ramp up. And actually, we're already thinking about increasing capacity of our station.
Will you then build new stations, because they will not drive 50 kilometers just to have a full tank again?
Very crucial point. I think one station does not found kind of ecosystem. You need to have at least 2 stations. You know, last year we had the luxury problem, so to speak, that after 5 years you need to check the tanks and you need to check all the, let's say, technical appliances that you have. And since we already started the station in 2016, in 2021 we had to reopen everything. So it was out of service for 2 weeks. That's not a long time, actually. If you drive a car, you take maybe a rental car at the same time, but as soon as you are a logistics company, that really hurts you. So as long as you have just one station around and everything is focused on having availability at that one very station, this will not convince the end user, the logistic company, to make use of it. I mean, just imagine being in their position. It's just too risky. So I think what you need at least is a pair of 2 stations, ideally a couple of more, that are within reach to overcome that point and to be able actually to kick it off and to come, what I said before, to come to speed.
Right. Mr. George, let's look at the side of the trucks we want to talk about, truck mobility in the future. There are at the moment almost no fuel cell trucks on the road. We have to admit that. The first 30 hydrogen fuel cell trucks from Hyundai will be on the road in Germany this year, probably, hopefully. What else do we have to do? Do we have to rebuild trucks?
So converting trucks from diesel propulsion systems to hydrogen propulsion is definitely one first step. So that's definitely our opinion in order to bring the vehicles to the market really quickly and to get the fleet operators in touch with the vehicles, to get the drivers in touch, to let them test and explore how hydrogen mobility works in the logistics sector, how refueling works with the proper refueling stations. So that's definitely one portion or one bit of the whole game. So definitely one first step.
I would be interested how you exactly do that. You buy the diesel trucks and build out the internal combustion engine and build in some fuel cells and a hydrogen tank, or how is it made?
So it's not so easy as you describe it, but basically that's it. So we are taking used diesel trucks, pull out the whole fossil diesel powertrain and the transmission and the axle, and then put in fuel cells, a buffer battery, hydrogen storage, and an e-axle, so an electric drive axle, and combine that with an intelligent software system to have an appropriate energy management system.
What do you do with the internal combustion engines? You throw them away.
You can sell it actually.
Okay.
So there is a market for that. So,
That's what you do. There's also, we've been talking about trucks now. What about fuel cell buses? It's pretty hard to find any fuel cell buses on the market. Do you do this rebuilding as well?
Absolutely. So in the eastern part of Germany, in the north of Brandenburg, we have a bus running on hydrogen in the national park. So,
Mr. Ivan, trucks and buses run usually on 350 bars, passenger cars on 700 bars. Most of your refueling stations run on 700 bars. Will you rebuild all your HRS now again?
No. So the business case we're looking at, as I mentioned, is the regional haul case with buses and trucks. So every new station in the next 3 to 5 years will focus on that. And as you rightly pointed out, one should think of customers and station at the same time today to make a project successful and to bring in scale, because scale only works if it's a business case or has a perspective to become a business case. So we cannot and will not add a 350 bar outlet to all the 700 bar stations. However, what we will do are 2 things. So first, there are some stations in very good locations where we will build a new station. And there are a number of stations where we're looking at let's say a small scale add-on for 350 bar, which will in itself not be a business case, but which can be an enabler to bridge 1-2 years in a relatively fast way, so that customers in that region can start with the first buses or first utility vehicles, whilst we build a bigger station, or someone else build a bigger station. And we very much welcome the fact that we are not alone here anymore. Sorry, we were not alone, of course, in the past, but there were, I think, 3 or 4 stations which were not operated by H Mobility, so less than 5% of the stations were not operated by H Mobility. Very much welcome the fact that others dare now, I have to say, to invest in the market as well. And it hasn't, the uncertainties have significantly increased, as you can see, with all the activity around us, and that's very good.
I know exactly. You came to the market when we had this hen and egg problem, and you said, "Well, let's build some hydrogen fueling station." That this argument is gone now, but maybe we should have taken it in another way from the right beginning. I just remember e-farm project. You know, they said, okay, we build hydrogen refueling stations at 2 places, Nibel and Husum. We have the buses there, we have the windmills there, we have all together, you know, the whole infrastructure. Will that be your next projects, or will you still focus on hydrogen fueling stations?
Now, our core business is and will be to invest in our own hydrogen refueling assets. So in refueling stations serving hydrogen at publicly accessible locations to customers. So that will stay in place. However, the two ingredients for a successful station are vehicles and the station, and the third one is production. And production will increasingly become visible as a bottleneck as well. The key bottleneck has been in the past years the vehicle supply. There are some signs that this is changing. There needs to be a lot of ramp up as well on the production side, and therefore we are looking at the moment into models how to collaborate. Let's say, let me put it like this, and it's still open in what intensity we will collaborate. Let's say with the production side, but we are looking into concepts. What is the best way actually to produce green hydrogen for those clusters we envisage, those regional clusters where trucks and buses will refuel.
So the 70 million you got from the investment fund Hy24 and another 40 million from your shareholders, they will run into new hydrogen refueling stations capable for 350 bars.
Yeah, around 2/3 of it will be invested in growth. So in the project I just described, in regions, regional haul use cases, always with 700 bar. So we will build the core station, which will serve most hydrogen around 350 bar for buses and trucks. But every station should as well have a 700 bar, because we want to keep that option in the game, definitely. And 2/3 of the money will go into that, and 1/3, roughly speaking, will go into optimizing and still operating as well the existing network.
Dr. Achter, Linde has the hardware chain for compressing hydrogen from 350 to 700 bar. Wouldn't it be possible to provide the gaseous hydrogen in containers at 350 bars and then compress it if it's needed, if a Hyundai or a Toyota shows up every once in a while, and then compress it just for them?
Well, there is a variety of concepts of how to deal with this, with the supply of different pressure levels when it comes to trucking of to refueling trucks. You can look into the Hydrostrider concept, for example, in Switzerland, how they do it, and the trailers they go to different stations, and then you have an extra compression into the vehicle. But you can also think about solving this problem in the compression side. So having a supply of hydrogen on a low pressure level, and then having 2 levels available for refueling. And we also have concepts for this. And this is something that we also want to make sure that we are very flexible when it comes to the hydrogen supply, as well as to the demand when it comes to customer needs, different vehicles that will be operated on that site. All of this can be managed, and one of course is also look into storage concepts. One crucial aspect is which pressure level you store your hydrogen in, and normally it's also an interesting idea of having a cascade of pressures because of the technical details that follow when it comes to the thermal management, for example. But this is something we're really flexible and can have concepts that are optimal for the requirements of the specific location.
Could you also imagine to have liquid hydrogen for heavy-duty trucks in the future?
Yes. I mean, we already have a technology that deals with the liquid supply. So we have a liquid supply of hydrogen, we put it into our cryopump, and we have then 350 or 700 bar fueling.
Okay, so you could give it directly liquid as it is.
This is already available. We have some stations that are operated, and we provide it to HT Mobility as well. We have stations running in California, And this is something we already do.
So I didn't get it right. In your trailers, you have liquid hydrogen that you bring back to gaseous form.
Exactly, in one equipment. So
But
we have
this, you lose a lot of energy with that, don't you?
well, you use your energy from the cryogenic state also for the thermal management. So you have those cryogenic hydrogen that can be optimized in terms of how you put your hydrogen into the fuel tank. When we look into the future, we see that we have a need to also make sure that the mass available inside the vehicle is high too, and is something that will be demanded by the OEMs of trucks. So we have partnered together with Daimler to have a new technology development called subcooled liquid hydrogen, where we directly transport the liquid hydrogen from the storage at the hydrogen refueling station into the vehicle tank, being still in liquid form, having a slight increase in pressure. This will make the mass available inside the vehicle much larger, enabling a large range that the vehicle can go. We have a small footprint of the hydrogen refueling station itself. We also have low energy consumption of the whole fueling process, which leads to tremendous decrease in total cost of ownership of that.
I will give you the opportunity to ask your questions. If there's any question already, please raise your hand. I will be the microphone right with you. There's the first one. If you just would introduce yourself, please.
Yes, I'm Georg Tinkhauser from Wien Energie and from the hydrogen department. And I have a question. So you mentioned liquid hydrogen as a fuel. Daimler is planning to, or announcing their Gen H2 truck to run on liquid hydrogen. What does H2 Mobility think about that? And are you planning to build up completely new stations for liquid hydrogen?
Ivan, what will you do?
H2 Mobility thinks the following. First, we need to scale this up. Otherwise, hydrogen will end up in a niche, right? And scaling up means that we focus on what's the next business case and what's the available technology to deliver that. And that is the 350 bar business case for the regional haul segment. And in addition, the 700 bar option for smaller quantities of hydrogen. So what we build now is the 350 bar high flow case and the 700 bar for smaller quantities. Let's say in the box, which answers the questions, what is the right form of hydrogen for the quantities or for the vehicles who require more than 60 kilograms in every vehicle, right? So the so-called long-haul case or other vehicles on the road. In that box, there are, for me, at the moment, 3 technologies. It may be 700 bar, it may be subcooled liquid hydrogen, or it may be cryo-compressed liquid hydrogen. 2 liquid hydrogen technologies, one at a lower pressure, one at a higher pressure. So those are the 3 technologies. And as a company who is now long-term or wants to become a long-term successful player in the market, we of course also need to strategically look forward and build competencies around these technologies. And in all 3 cases, we are currently talking to partners to talk about the first pilot projects. Right? Our focus is the commercial case now, and we are about to pilot these technologies to gain competencies. And when the time is ready for a rollout, and when the market has decided which of those it will be, I think the market will decide, not politics probably in that case, then we are ready.
Dr. Dohn, will Westfalen AG build fueling stations for liquid hydrogen?
It's a very good question. Before coming to that one, I would like to add something, because I think we are, especially in the let's say almost very similar situation. I think we're always looking on an infrastructure versus truck concept. We put it in a bubble. We say there's a truck and there's a refueling station, and they have to interact, and maybe it's gaseous, maybe it's liquid, maybe it's cryo-compressed or whatever. They all have their advantages and disadvantages, but we usually look at it in a bubble. We don't leave the bubble. Westfalen, by coincidence, we are actually covering the entire value chain, from hydrogen production to hydrogen transportation to application in the refueling station. And we think that the discussion, taking just the bubble, the truck and the infrastructure, is just too short. I think we have to look at the entire infrastructure, at the entire, let's say, value chain that is starting at the production. What we see today is that you have gaseous hydrogen available in large quantities, and you have liquid hydrogen available in, let's say, not so large quantities. There are advantages, there are disadvantages. Especially in the north of Germany, everyone is discussing about big pipeline networks. Everything is discussing that big industrial customers are, let's say, having a pull effect on more hydrogen molecules, and that there is a pipeline network going to be, let's say, built up, pulled by the industry. But that, of course, can be utilized for mobility applications if you connect those new hydrogen refueling stations to the pipelines. And what happens then is that you have gaseous hydrogen molecules available at the inlet of the compressor to your refueling station. In such case, for me, I currently, status today, don't see any reason why we should liquefy that hydrogen and bring it then in liquid form into the trucks. On the other hand, there's a function of time that we have to see next to the pure technology question. Today we're discussing about gaseous hydrogen. In future, there may be liquid hydrogen imported from overseas. And we see that Westfalen has actually, since 40 years, we have climate-friendly fuels like LPG, we have CNG and also LNG. LNG, that's the liquid form of natural gas, and it's imported. So we don't liquefy it in Germany, it's imported in liquid form, we keep it liquid. So as soon as you have that available, large quantities to, let's say, at affordable prices from overseas, I don't see any reason why there shouldn't be any liquid structure forming up next to the other one. And once more, we have made the experience in the last 40 years that there can be several forms of fuels applicable at the very same time, all having their, let's say, roles in their niches. I make an example. Since 100 years, you have diesel and you have auto fuel for combustion engines. So for one such thing as combustion engine, you already have two types. Then in the last couple of years, you have CNG, you have LNG, and it's all coexisting at the same time, all fueling one or the other niche. So I lack the imagination why it shouldn't be possible to have gases and liquid at the same time, as we have today, 700 and 350 bar at the same time. So what is going to evolve in the future, from our perspective, is actually not so important. It will evolve. We're not able to handle all those different aspects. It will happen one or the other way. I think what is most important is that we keep that in mind, that there are different technologies and they all have their advantages and disadvantages, and that we have to remain flexible and open-minded and need to, let's say, have access to those technologies so that the whole market can participate.
Dr. Dohn, but how confident are you that trucks will run on hydrogen at all? You know, if we might get some e-fuel derivatives so imported, and then the market may change completely, and we have the old internal combustion engine again, and you would be happy probably not to change your infrastructure too much.
I'm not sure we're happier. I mean, we are a family-owned company, and what we want to do is we want to be part of the solution. I mean, currently we're bringing into the market lots of classic fuels. We want to be part of the solution. We want to be greener, and hydrogen is an excellent opportunity to do so. Coming back to your question, I think that you said in the beginning we have to reduce emissions, and by 2030 it's roughly half of all emissions in the mobility sector. And out of that half of the emissions, it's the easiest way to just look at heavy duty. Currently, we have in the range of 3 million heavy-duty vehicles, and 1 million out of this is responsible for 1/3 of all mobility emissions. So if we're able to tackle that 1/3, we did a lot already. And we don't have so many options. We have the options you said, e-fuels. That's a very good option. You can leave the infrastructure as it is, and probably we would be happy. On the other hand, that consumes lots of energy, and why taking hydrogen, taking it to another form, have losses on the way, and then go into the, let's say, classic route? If you have hydrogen available at large quantities, especially where you have a pipeline, why not going for hydrogen as a fuel directly? I mean, what we're talking about currently is we think one or the other thing. I would like to underline, I think it needs to be a mixture of everything. When we look at about hydrogen, or when we're talking about hydrogen, we have hydrogen not only in mobility, we have hydrogen as a, let's say, essential molecule for how I say, industry,
Or the industry,
And it will be there. It will be there. On the other hand, we're talking about what we call in Germany Energiewende. I think it's an international word by now. Energiewende means that we need to, let's say, harvest the energy, the renewable energy that will be fluctuating. And we do so ideally by hydrogen. So there will be hydrogen available. And before, I mean, you can take that hydrogen and turn it back into electricity and then put it to battery electric vehicles, to put it to other applications. I think if it's there, it makes sense to think about applying that hydrogen without any other form of change, any other loss incorporated, applied directly to a truck. And that's one of the, in our eyes, best versions to come to a climate neutral mobility sector without changing, let's say, our whole infrastructure.
But first, we have the renewable energy, Mr. George, and I've seen the battery technology has made enormous progress in the last years. They're becoming smaller, they're becoming more powerful, they're becoming cheaper, and we might see also batteries in heavy-duty trucks, or you don't believe it. We see them already in buses, we see them in light commercial vehicles, why not in heavy-duty trucks? What do you think about that?
So I think we will also see them in heavy-duty trucks, and it all depends on the use case. So when you want to drive long distances, you are really limited with batteries, especially when it comes to the refueling or recharging infrastructure. So when you just imagine all of the trucks at night at the gas stations on the German highways, and now imagine how to recharge them all with hyperchargers. In my opinion, this is not really solvable. So we really see the advantage of hydrogen when it comes to long distances. But when we are talking about short distances, even in the heavy-duty sector, batteries can also be a solution.
I sometimes talk to automotive engineers and they tell me, well, fuel cells are a nice opportunity, but when it comes into mountains and mountain range and the velocity is not that high, we don't get enough cooling for these heavy-duty trucks. Did you solve that problem already?
So that's definitely a challenge because due to the limited temperature gradient between the cooling fluid of the fuel cell and the ambient, you need way larger coolers for fuel cells. So we already made a lot of progress in technical development, and there will be also other cooling concepts on the way we see at the moment. I'm quite sure that we will solve this problem. And at the moment, from the tests we did, it's not a big issue at the moment. So our trucks definitely can solve that.
Okay, good to hear. Mr. Ivan, what do you think about these overhead lines for trucks? The National Platform for Future of Mobility recommends to build 4,000 kilometers overhead lines in Germany. You hate them probably, don't you?
No, but my answer is very short. I don't think much of it.
You don't believe it will come, will it?
No.
Well, the platform, National Platform for Future of Mobility is quite influential, isn't it?
Yeah. Yes and no. I mean, I think in maybe in other countries, same happens. But in Germany, we tend to discuss like if we were on an island and the energy transition would just happen in Germany. I mean, I don't know. I couldn't name one European market who is seriously discussing about rolling out this catenary concept. And what about the rest of Europe? What about the rest of the world? Yeah, this requires a lot of coordination, besides the fact that I think technically and economically speaking, there are much smarter concepts than this. So I wouldn't invest too much time and energy, but others do, I know. And I can't tell them not to. So I observe it and sometimes think. Well,
we will see. It's a competition, yeah. Right.
No, I don't see myself in a competition with this. I don't think it will be a big topic, long term. No.
I have Sven Geitmann here having a question.
Sven Geitmann, H2 magazine. My question is about hydrogen costs. I heard that the costs of H2 will rise at the filling stations. Perhaps Mr. Ivan can explain why the costs will rise, and perhaps the other partners on over there might explain if they are in a good mood or if it's good or bad for the ramp up of hydrogen cars.
Would you like to answer this question, Dr. Acher?
I think the first one was from Mr. Ivan.
Okay.
Who doesn't want to answer questions about rising costs? I mean, as you may have seen, or some may have seen, we yesterday communicated to our customers that we will also increase the hydrogen prices. So energy costs, or the cost of every energy input basically has risen sharply in the past months. So between 30 and 50% when you look at power for charging or fuel like gasoline or diesel. And we will increase our prices by 35% in 1 week. So that is just reflecting the reality that all the input costs are rising sharply, especially the energy input, be it power or natural gas. So having said that, looking into the future, what needs to happen in the hydrogen space is that hydrogen needs to be more and more produced by renewable power or as a feedstock. And this renewable power ideally comes from surplus power, so the electrolyzers should serve a purpose higher than just producing hydrogen. They also should serve a purpose to stabilize the grid. And they should use power from connection to a renewable power source, be it over a power purchase agreement or directly connected to a windmill or wind turbine, I should say, or photovoltaic solar panel. Therefore, I think there are good reasons to believe that the cost of hydrogen in relative terms, so compared to alternatives, the cost of hydrogen for customers will be very competitive in the future and will increasingly be more competitive in the next years. But here we're looking to the next 2, 3, 5+ years.
You would agree to Mr. Ivan, Dr. Acher?
Yes, I would agree to that, but maybe also tackling the second part of your question when it comes to the business case or the impact on the business case of the hydrogen refueling stations. For us, the key parameter here is the total cost of ownership of hydrogen. So there's the hydrogen cost itself is only one aspect of this whole key parameter. And I think we still look that this is decreased in the future, although the hydrogen price itself is on a slight increase at the moment. And what for me is even more important when it comes to how much business is involved in the hydrogen refueling stations is what we see here is the interest in those projects, is the realization of those projects, and I think there we can see a dramatic uptake in the last month.
Ladies and gentlemen, we are running out of time, unfortunately. I know there's another question, but I hope you can ask that personally to one of these gentlemen or to all of these gentlemen. Thank you very much for this discussion here on the panel. Thank you for being here, and thank you, the audience, for your interest.